A new report confirms the moose population in Minnesota is declining sharply. 30 years ago, in the northwestern part of the state, there were more than 4,000, but tonight there are fewer than 100.
In the middle of winter, hikers in Maine started seeing ghosts. Huge animals, 6 feet tall, pure white. Not because they were rare, because they had rubbed their fur off trying to escape something eating them alive. By the time biologists caught up, the damage was already done. Organs pale, blood gone, bones hollowed from the inside. This wasn't nature being cruel. This was nature breaking. The first clue wasn't found in the snow. It was found on a computer screen. Biologists at Maine's Wildlife Department had been tracking newborn moose calves using GPS collars. Each collar sent regular signals. As long as the dot moved, the calf was alive. Then the dots began to stop. At first it was 1 or 2. That happens every winter. Cold is hard. Food is scarce. But then more signals went flat. And then more. Entire stretches of forest went quiet. By spring, the numbers were impossible to ignore. Out of 70 calves fitted with collars in one region, 60 were dead. That's not a population dip, that's a collapse. What made it worse was how clean the deaths looked. No tracks from wolves, no claw marks from bears, no blood in the snow. If predators had done this, there would be chaos at the scene, torn hides, broken bones, a struggle. Instead, the calves looked like they had simply shut down. When biologists recovered the collars and examined the bodies, they noticed the same thing again and again. The animals were dangerously thin. Their ribs showed. Their legs looked too weak to hold their weight. This didn't look like starvation caused by lack of food. The forest was full of browse, twigs, shoots, everything a moose should need. Something else had taken their strength long before winter ended. Something slow, something patient, and it wasn't finished when the animal stopped moving. Because when the biologists finally opened the bodies, they realized the real damage wasn't on the outside, it was under the skin. And once they saw it, there was no way to unsee it. When biologists began the necropsies, they expected answers. They did not expect horror. The first thing they noticed was the color, or rather the lack of it. Healthy organs are deep red, rich with blood. These weren't. The livers looked washed out. The muscles were pale. Even the heart looked faded, like the life had been drained from it long before death. That kind of coloring means one thing: anemia. The animals hadn't just lost weight, they had lost blood. Then the fur started to shift. As the biologists pulled back the hide, the skin underneath was crawling. Not a few insects, not dozens, thousands. Ticks covered the calves from neck to tail, packed so tightly they formed living layers. Some were small, others were swollen and gray, bloated with blood. On one adult cow, the team stopped counting after 90,000. 90,000 parasites feeding on a single animal. This wasn't random. Every calf showed the same pattern: massive blood loss, severe malnutrition, no sign of disease, no wounds. The moose weren't being hunted. They were being harvested. Each tick had taken only a drop, but together they had drained liters of blood over the course of winter. The calves never had a chance to replace what was lost. By the time they collapsed, their bodies were already empty. This was no accident. It was a system working exactly as designed. But the question still remained: why now? These ticks weren't new. They had always lived here. For thousands of years, moose and ticks shared the same forest. So what had changed? The answer wasn't in the animals. It was in the air. The creature responsible doesn't chase, it waits. It's called the winter tick, and it doesn't live like most parasites. Most ticks feed once, fall off, and hope they survive long enough to find another host. The winter tick plays a different game. It commits to a single animal for life. In early fall, millions of tiny larvae hatch on the forest floor. They crawl up grass stems and saplings and lock their legs together, forming dense clusters. To the naked eye, they look like dark smudges on the leaves. They wait. When a moose passes by, the cluster explodes. In seconds, thousands of larvae transfer from the plant to the animal's fur. They don't bite right away. They move inward, burrowing through the hair until they reach skin, and then they stay. All winter long, the ticks feed, grow, and feed again. Larvae become nymphs. Nymphs become adults. Each stage needs blood. By late winter, the females swell to the size of grapes, gray, heavy, hanging from the skin in clusters. One moose can pick up tens of thousands of ticks in a single day. Some carry far more. Moose are especially vulnerable. They didn't evolve alongside this parasite. They don't groom effectively. By the time they react, the damage is already done. The tick has found the perfect host, a massive animal, thick fur, slow response, a walking blood bank. But even this doesn't explain the scale of the deaths. Parasites usually exist in balance with their hosts. They don't wipe them out, unless something tilts the balance. And in Maine, something did, because winter stopped arriving on time. By late winter, the damage becomes fatal. Each fully grown female winter tick drinks about 1 milliliter of blood. That doesn't sound like much, but multiply it by 30,000 or 50,000 or more. That's liters of blood pulled from a single animal. For a calf, that kind of loss is catastrophic. The body tries to fight back. It burns stored fat to make new blood. When the fat is gone, it turns to muscle. When that's not enough, it consumes the marrow inside the bones. During necropsies, biologists check the femur. In a healthy moose, the marrow is thick and white. In these calves, it was red and watery, a clear sign the animal had been running on nothing. The ticks don't just drain blood, they drive the moose mad. Thousands of bites itch constantly. The animals stop feeding. They spend their days rubbing against trees, scraping their hides raw. As they scratch, they rip out their own fur. That fur is their winter armor. Once it's gone, body heat pours out. The moose burns calories just to stay alive. In deep winter, there are no calories left to burn. Starvation, blood loss, hypothermia, 3 killers working together. Some adults survive, but at a cost. Pregnant cows lose calves before birth. Others are too weak to breed at all. The population doesn't just shrink, it fails to replace itself. And still, the ticks keep falling to the ground in spring, laying eggs by the millions. The cycle resets. Unless something breaks it, and the force that strengthened the ticks came from far beyond the forest. The moose didn't just face ticks. They faced a forest changed by humans and climate. Logging created a buffet. Clear-cuts left dense shrubs, willows, and saplings, perfect food for moose. Population soared. In some areas, up to 40 moose crowded every 10 square miles. That density was a dream for ticks. Each animal became a moving host, walking through forests thick with parasites. More hosts meant more survival, more reproduction, more devastation. Then there was the weather. Winters used to arrive early in Maine. Frost would hit in October. Snow would cover the ground by November. For the ticks, that was a death sentence. Millions froze before they could find a moose. Now, fall comes later. Snow holds off. Milder temperatures stretch the questing season from a few weeks to months. The tick larvae crawl longer, survive longer, and infect more hosts. It's a perfect storm. A forest reshaped by humans, a warming climate, moose packed together like sardines, and an ancient parasite suddenly unstoppable. Even the strongest animals couldn't fight it. Moose calves died in clusters. Adults suffered and failed to reproduce. The ghostly moose sightings weren't isolated. They were everywhere. The system itself was broken. And the solution? It wasn't in the forest. It wasn't in the ticks. It was in the moose. To save the species, biologists considered something that sounds impossible. Biologists were faced with a brutal decision. The tick infestation wasn't going away. Warmer falls had extended the parasite season. Moose densities were still high in many areas. Calves were dying faster than the adults could reproduce. So the solution seemed almost unthinkable. Reduce the population to save the species. In 2022, wildlife managers split a study area in two. In the western half, they let nature take its course. In the eastern half, they issued more hunting permits, specifically for antlerless moose, cows, and calves. The goal wasn't to destroy the population. It was to lower density, reduce the number of hosts, and break the tick's life cycle. Early results were staggering. Moose in the cold zone had far fewer ticks. Calves survived at higher rates. Adults were healthier. The density-dependent theory worked. But the human reaction was volatile. Many saw it as cruel, even barbaric. Killing some to save the rest seemed impossible to justify emotionally. Yet the data didn't lie. Doing nothing guaranteed more death. The forest was no longer neutral. The ecosystem itself had become a battleground, with humans deciding who lived and who died. And yet, even with these efforts, the threat was not contained. Ghost moose continued to appear in nearby regions. Brainworms and other parasites preyed on weakened animals. Every surviving moose carried the scars of winter. The horror wasn't just local. This was a warning, a glimpse of what happens when climate, habitat changes, and ancient parasites collide. Because in Maine, the moose are just the beginning. And in the Northwoods, the forest is still listening. Even after interventions, the forest holds its secrets. Ghost moose still wander the trails, their pale hides of warning. Calves that survive are smaller, weaker, forever changed by the winter tick's relentless assault. Adults carry the scars of past infestations, their bodies running on reserves that may never fully recover. And the ticks, they wait. Patient, unstoppable, multiplying quietly in the underbrush. Each fall, new generations hatch, crawling up stems, ready for the next host. The forest itself seems complicit. Dense shrubs, regenerating clear-cuts, warmer temperatures, all feeding a cycle that humans struggle to control. Climate change is a silent accomplice. Every warmer fall extends the season, giving ticks more time to feast. Every late snow leaves larvae alive and hungry. What was once a manageable balance has tipped into catastrophe. The question now isn't whether the moose can survive, it's whether humans will act fast enough to save them. And even then, the solution demands difficult choices. Fewer moose to save the many, chemical interventions with unknown consequences, or letting nature continue its brutal course. Walk into the woods today, and you may see the pale shapes drifting through the snow. Ghosts of a system that failed, shadows of a collapse already underway. And the forest waits, silent, watching, patient, because no one knows exactly how far the nightmare will spread. Will Maine's moose survive the next winter, or will the ghosts claim them all?